All right, sorry for that weird stopping point. My computer decided to stop recording. So we are going to now look at question 5. It says the following table shows the number of credit hours a student took in the first semester at Coastal and their GPA at the end of the semester. So I have a table. I know more than likely I'm going to have to end up doing a list 1 and a list 2. And then I double check it because at A it says use your graphing calculator to find the equation. Okay, so that tells me I'm immediately going to go into stat, enter. I'm going to go up to the list 1. I'm going to clear it out by hitting enter. List 2, clear, enter. All right, now everything's reset, and I'm going to start going in and putting in my 5, 10, 15, 18, 12, and 13. And then I have 4, 3.5, 3, 2.5, 4, 3.5. Okay, so now everything's even. Double check my answer, or check my input. And I'm going to do a linear regression. So stat calc 4. And let's see, I'm going to use the model to predict. So I know I'm going to go vars, y vars. And I'm going to hit enter, enter, enter. And I have my equation. And it says to the nearest hundredth, so 2 decimal places. So I have y equals about negative 0.11x plus 4.76. Okay. Now it says use the model to predict the GPA of a student who takes 9 credit hours. So I'm going to go and hit second table set. I'm going to change that to 9, hit enter, and then really quick I'm going to go to my graph, and it says, oh, it's 3.7664. Let's see, round your answer to the nearest hundredth. So I'm going to do 3.77. So 3.77. My favorite little button is that second table set. It immediately jumps to the answer that I'm looking for. Okay. Question 6 was going to start our test review for day 1. Again, this is a review. It's things that you should already know how to do, but they're a little bit more complex and incorporate a few extra things. Okay, it says find the equation on the line that passes through the point 2, negative 1, 1, 7. Well, we already know the first thing that we're going to do is we're going to have to find our m. All right, let me make this bigger really quick. And to find our slope given 2 points, we know we're going to do y2 minus y1. So we have 7 minus negative 1. And then we're going to have 1 minus 2. 7 minus negative 1. If we remember, right, that negative cancels out to be a positive. Sorry, guys. Okay. So that we get 7 plus 1 is 8. 1 minus 2 is a negative 1. Well, this just becomes negative 8. If we're finding an equation of a line that passes through a point, I prefer to use y minus, well, it doesn't matter which y, but y2 is equal to mx minus x2. Okay, it doesn't matter which one you use as long as you use the same point. All right, so I have y minus 7 is equal to negative 8 times x minus, if I use 7, I'm going to use my 1. So y minus 7 is equal to negative 8x, and then negative 1 times a negative, or negative 8, negative 1 is a positive 8. I'm going to add 7 to both sides so that I get y equals negative 8x plus 15. All right. Paul purchases a 2016 BMW in the year 2018. Ooh. And in 2018, the car was worth $25,000. If the value of the car is $20,000 in 2020 and the rate of depreciation is the same, what will the car be worth in 2023? So, first of all, we're going to eliminate some excess information. This is to confuse you right here. The information that we need is in 2018, the car was worth $25,700. So I know I have 2018 was worth 25,700. And then in 2020, car was worth 20,100. I know I'm going to have to calculate the equation so that then I can find out the value of the car in 2023. Now, I also want to teach you, hopefully you have already realized this, you can also have your stat button find your equation for you. We know 2018 and 2020. 2018, it was 25,700. 2020 was 2,100. We're going to do stat calc 4, and we're given our equation. We no longer have to calculate m. We don't have to calculate anything else. We just plug it into our calculator, and it's going to give us our equation. We're just going to plug it in so that we get y equals negative 2,800x plus, hold on, something's not quite right, because that's 5 million. Oh, right, that's right. Okay, if I notice that my b is like 56 million or 5,676,000, we did something wrong. And I'm going to fix it, and I'm going to show you how to fix it whenever you're calculating. All right, 2018 is actually our starting year. 2 years later is 2020. Now we're going to go in stat calc 4. Now we get our 2,800 and plus a starting value of 25,700. My apologies, guys. So 2018 ended up being year 0 and 2020 ended up being year 2. Okay, so we have our equation. And now we're going to look for the year 2023. So I'm actually going to plug in 2023, by the way, is how many years later? Well, 2023 is 3. No, I'm talking about 5 years after 2018. So I'm going to be y equals negative 2,800, and I'm going to use the number 5 plus 25,700. So I'm going to plug it into my calculator. Times 5 plus 25,700. We have a value of $11,700 in the year 2023. All right, so now our next question is we're going to solve each quadratic expression. We're going to express each answer in radical form. No decimal answers, meaning I want exact answers. Decimals are not exact answers. So, A. Okay, we're going to do A first. Well, I'm going to look at it. I have a 4 and a 5. So what times what gives me 4 but adds to be a 5? Well, I should know by now. My value should be x plus 1, x plus 4, because they multiply to be 4 and add to be 5. So if I were to solve them, I get x equals negative 1 and negative 4. B. Wow. B is a little more complex, but that's okay. I'm not scared of it. Sorry, guys. There it goes. Okay. All right, so B, I'm going to rewrite it over here. I have negative 2x minus 1 squared equals negative 6. Instead of trying to multiply this all out, what I'm actually going to do is make it so that my square is by himself on one side and my value is up by itself on the other side. So I'm going to actually divide by negative 2. So that I get x minus 1 squared is on one side, and negative 6 divided by negative 2, positive 3. Okay, now I'm working with something that I kind of recognize. How do I get rid of a square? Well, I take the square root. So I get x minus 1 is equal to, well, this will end up being plus or minus the square root of 3. Move that 1 to the other side, and I get x equals 1 plus or minus the square root of 3. And that's my final answer. You don't always have to overcomplicate it. Sometimes you just have to look at it and go, I know that this could be a square on one side, so I just need to move everything else to the other. All right, looking at C. This is a trinomial with a lead coefficient, but in this case, I know even if I were to take and multiply that 7 to the last number, I get a negative 70. I can't have anything that multiplies to be negative 70, but adds to be a positive 1. So now I know I'm going to have to do A equals 7, B is 1, and C is negative 10. I'm going to have to use the quadratic formula. I have no choice. So I'm going to do negative b plus or minus the square root of b squared minus 4ac all over 2a. I get negative 1 plus or minus the square root. I get, let's see, I'm going to do 1 squared minus 4 times 7 times negative 10. I get a 281 underneath my square root. So square root of 281 over what ends up being 14. 281 is not divisible by 2, which means it's not divisible by 4. And 281, cool little trick. If you add 2, 8, and 1, 2 plus 8 is 10. 10 plus 1 is 11. 11 is not divisible by 3. Therefore, I cannot break this down any further. My answer is negative 1 plus or minus the square root of 281 divided by 14. All right, 9. Jack throws a baseball at a velocity of 20 feet per second. And if Jack is 6 feet tall, what is the maximum height that the ball will reach? And when will it reach this height? There is a standard term that we have to use in this when we're talking about height and time. So to write my equation, I know it's h of t, height given the time. It always starts with a negative 16 t squared. Now I'm going to use that 20 feet per second. So that's plus 20. T is that feet per second. If Jack is 6 feet tall, what is the maximum height of the ball? Meaning the ball will start at 6 feet when it is thrown. It says, when will it reach the maximum height? So I actually need to take this and I can plug it into my calculator, right? So we're going to go into y equals. Our handy dandy calculator, I'm going to turn my plot off, that way it's not distracting. My handy dandy calculator is exactly what I need to use. So I have negative 16. And instead of t, I use x because we don't recognize t in the calculator. Plus 20x plus 6. I'm going to take a look at it. Well, first of all, I'm going to zoom 6 and reset my calculator. And now I'm going to take a look at my graph. Okay, so I see my graph. I can't see it very well, but I can see it well enough. I want to know, what is the maximum? Well, now I do have to change it around. I'm going to have to actually zoom fit. Maybe zoom fit. Let's see what it looks like. If I can see all of it. Nope. Yep. Zoom fit works. Okay. So that gives me my maximum. So I'm actually going to take and I'm going to say second calc. I'm going to calculate the max. Now, if you don't want to do it via your calculator, you need the left bound. Go far enough to the left. Right bound. You're just going to hold it until you get far enough to the right. Again, I am doing this pretty far over. Enter, enter, enter. We have a maximum height of 12.25 feet at 0.625 seconds, because we're talking about seconds. So X is always your time, Y is always your feet, or your height. So we have a maximum height of 12.25 feet at 0.625 seconds. Now it says, when will the rock hit the ground? All right, I'm going to go and take a look at my graph again. I'm going to actually zoom fit it. So zoom 6 is zoom fit. It resets everything. And when I'm talking about where it hits the ground, if I were looking at the x-axis as my ground, I want to know, where does it hit the x-axis? And again, because it's a ball, it can't be on the negative side of it. It has to be on the positive side of it. Can't go back in time. So I'm going to do zoom, or second, calc. I'm going to calculate the 0. Remember, I'm actually going to go all the way over so that I'm above the line. Oops, I went too far. Above the line. And then I'm going to go below the line so that I can get a nice, I never do a guess, so I hit enter again. And the 0 occurs at 1.5. So when will it hit the ground? It will hit the ground at 1. So it hits the ground at 1.5 seconds. Now, if you did not want to use your calculator to calculate anything, you could actually do negative b over 2a to get your x, and then of course plug it in to get your y. But I didn't want to do that. I wanted to use my calculator for it. Okay, for D. Oh, sorry, for 10. Actually, you know what? I'm going to hold the video there. I will start part 3 with day 2.